Okay, Bismillahirrahmanirrahim. We start our lecture today. Okay, today we are discussing about the introduction to the Z formal specification languages. Okay, this one is the Z notation. The Z notation. Okay, okay, what is a Z notation? Okay, as you take a look, the formal specification is using mathematical notation to describe in precise way the properties which an information system must have without unduly constraining the way which these property are achieved. Okay, they describe what the system must do without saying how it is being done. And then we are using also abstraction to make formal specification useful. Okay, one way in which this one is using mathematical notation to achieve this goal. Okay, these data type are not oriented towards computer representation, but they obey a rich collection of mathematical laws. Okay, the main ingredient in a Z notation is a way of decomposing a specification into a small pieces called schema. Later we see the schema. Okay. Okay, this one is a schema used to describe both statistic and dynamic aspect of the system. Dynamic, okay. And then the other one is static. Okay, boleh baca ke tulisan saya? Okay, dynamic and static. Okay, for the static, okay, for the static, we okay, okay, for the static, it occupy the some of the aspect, include the state. We have the state. Later we see this one, invariant. Okay. Then for the dynamic, includes the operation that are possible. Okay. Relationship between input and output. Okay. Between input and output. Okay. And then the changes of the state. Okay, boleh. Okay, we have a schema that split it into two types of category. First one is dynamic, second is static. For the static, we look into the state and invariant. Invariant is a relationship that are maintained as the system move from state to state. So any question? Is it okay? Okay, and then Z as a specification language. Okay, Z as specification language are based on the set of the theory lah. Okay, based on a theory set and has been developed at the programming research group at the Oxford Computing Laboratory since the late of 1970s. Okay. Okay, probably now the most widely used specification language. Okay. Okay, and then it has been introduced by the researcher named John Raymond Abril. The name was John Raymond. Okay, this one in the late 1974. Okay, he used the notation that would later be taught in the University of Grenoble until the end of late 1980s, which Abriel wrote the internal notes on Z, and then the Z notation is used in the 1980 books methods the program. Okay, Abriel has been said that Z so named because it is ultimate language, although the Zarmelo, okay, the Z stand for Zarmelo. Okay, also associated with the Z notation through is Zermelo-Fraenkel set theory. This one is basically is a set of theory. Okay, and then Z specification language. Okay, this one specification I built from component called schemas. Okay, later I lay out what is a schema, and then for the Z itself is based on the mathematical notation used in a axiomatic set of theory. Okay, then we use in the lambda calculation, and then we use also in the first order logic. Okay, can you read my handwritten? Boleh baca ke? First order logic predicates. First order predicate logic. Okay, all expression in Z notation are typed, thereby avoiding some of the paradox of naive set theory. Thereby avoiding some of the paradox of set theory. And Z notation, Z contain a standardized catalog. Okay, standardized catalog, we name it as a schema. Okay, we name it as a schema. Okay, so far do you have any question? Ada soalan ke? Okay, schema language is used to structure and compose mathematical description. Okay, to compose the mathematical description. Tak clear. Mathematical description. Sounds good. Collecting pieces of information, encapsulating them, and naming them for reuse. Okay, schema specification based on the building blocks. Okay. In second component of Z notation, the first being a mathematical language of set logic and set of theory. No? This one is based on the logic and set of theory. And then in Z, we use the graphical representation of schema, make Z specification easier to understand. Okay, we simply simplify our formal specification by factoring out patterns and declaration and also the constraint. And then mathematical notation of schema allows of building a formal completeness and consistently proof to validate the specification. Uh, okay. Later we see formal specification. Okay. Okay. For example, we have soul. Soul. Yeah, soul. And then we have a seat. Then we have partial for the customer. And then we have seating here. And then we have P, power offset seat. And then we have constraint, domain, so, okay, seating. Okay. Okay, schema is part of the declaration and constraint. Okay. Okay, schema introduce specification entity and define invariant predicates over the entities. Okay, a predicate is also known as a Boolean expression. Some predicate can be have side effect that change the state of entities involved. Names are local to schema. Okay, if you look the schema representation, brush. Okay, we might have the declaration. Okay, declaration here. Tak clear. Tak ada. We have declaration. Clear tak? Boleh baca tak? And constraint. Tak clear lah. Sudah pen lah. Okay, this one in the horizontal. We have horizontal. And then we have vertical. Okay, vertical we have like this. Okay, and then we have declaration. And then we have constraint here. Okay. In vertical form, we might make a light some semicolon between the declaration. Later we see semicolon. It's fine. And then conjunction between the predicate. We use the conjunction in the predicates. Okay. Okay, do you have any question? Ada soalan ke? Alright. Okay, Akila ada soalan, Afika? Ada soalan ke? Kalau ada, bagi tahu lah. Okay, what is invariant? Invariant is a value or condition. Normally we have a value or condition that expected to be consistent during the execution of the process. Okay, this one is invariant. In mathematics, invariant mean specifically unchanged by specified mathematical or physical operation. The process is by mathematical process, math process. In many respects, Z schema are akin to object. It's more likely to object. Okay, this one is a problem. We have some cases here. Storage tank is monitored by a control system. The system consisting of a container which can hold something, and a indicator panel which shows the current field level and the danger level. We have two conditions here. First, current level, and second is danger level. If the storage tank goes over the danger level, a warning light must be lighted on the indicator panel, and field operation must be specified as to ensure the tank to be refilled but never overfill. Okay, this one is the condition. Condition. Okay, that we are speaking just now is for the invariant structure of dynamically system is defined as equivalent relation. This one is equivalent relation. If you fill the level and then the storage tank is goes over the danger level, and then a warning light must be lighted. This one is invariant. Invariant means that it has classes that are carried invariantly by the state transition function. We have state here. First is the danger level. First is the field level, and second is danger level. Okay, this one is container specification. This one we have vertical or horizontal. Haziq, Haziq ada? Haziq, Muhammad Haziq, Daniel? Tak ada ke? Fatin? Fatin Syafawani ada? Ini bentuk apa ni? Vertical, vertical forms. Okay, this one is a vertical form. We have semicolon here. Okay, and then we have a naming schema. Naming schema. We have we may give a name to schema, which have a schema name. Okay, and then we have variables, declarations, and then we have schema predicates. Okay, schema predicates. Okay, and then it introduces schema name, which equivalent to uh, container must be a schema expression. Okay, here we have schema, and then to container. Okay, content is equal to n natural numbers. Capacity also natural number, and then content we have invariant here that defining by the specification. Specification that has sum of invariant less than or equal to, greater than or equal to. Okay, less than or equal to capacity. Okay, and then design notation must include the name, signature. We have name and signature, introducing the entities of their type, and then predicate. A predicate part defining the relationships between the entities in the signature by stating the logical expression which may always be true, that declared by the invariant, depicted by invariant. Okay, and then you can set two schema can are said be equivalent if they declare the same of set identifiers which have the same type and impose logically equivalent constraint upon them. Okay, okay this one when you are using schema, we may use the schema name in place of declaration. You must declare. For example, here we have a container. After quantify in the set comprehension in and lambda and mu expressions. In the place of predicate, in this case, only the constraint part is important in place of set. Here we have invariant here, schema predicate. You can use the set. Use the set. Okay. Okay, this one is indicator that we have some of the place of indication. We have light, two condition here, off on and on, and then we have a reading, danger level. We declared by the semicolon n is natural number, and then we have invariant. Okay, if the storage tank goes over the danger level, a warning light must be lighted on the indicator panel. This one is the specification that described uh, by the predicate. Okay, define the relationships. Okay, by using invariant. Okay, and then we have specification in terms of indicator. We have first one we have a container, and then we have indicator, storage tank. Okay, this one is reading. The specification must read the content of the storage tank to use the invariant. Okay, and then we have content. We combine storage tank with the readings here, and then we have capacity and danger level. Okay, and then we have feel okay. Okay, before this we have a set notation. Okay, and then okay, feel okay, and then we have delta like this, and then we have z like this. Okay, and then this one for the input eh, uh, sorry, and delta, and then we have z. Later I explain. Then this one as an input, this one as an output. Okay, for the delta, we have declarative. Uh, okay, this one is if we put the z symbol, it means is the not change. This one is not change. Delta mean the storage tank is changed. Okay, this one is changed. Okay, and then we have the input name. We have input as amount, and then we have precondition and postcondition. Okay, this one is we use the single quotes, single quote to variable name after the operation is performed. Means the variable after here. The single quote is the variable after the operation performed. Okay, Aiman Zakri okey ke? Kamu okey ke? Kamu dah tidur ni? Okey, boleh eh? Jangan tidur eh. Okay, remember, please remember that delta it changed the operation, and then for the z symbol is the operation is not changed. Okay, and then uh, question mark for the input, and then exclamation mark for the output lah. And then in specifying the operation, we must consider the precondition and postcondition. The precondition, the operation, the things that must be true for the operation to be success. And then the postcondition, the things that will be true after the operation. And then the precondition was satisfied before the operation. Okay, this one is pre and post. Okay, ni pre and post. Okay, Aliana Akila, okay, okay, this one is a Greek letter delta. It means that the operation changes some or all the state variable introduced in the schema. A variable name decorated with the question mark represent input, and then variable name decorated with the quote marks represent the value of state variable n after operation. Okay, after operation perform. Okay, and then we have a Z convention continues. Schema name prefixed by the Greek letter Z means that define operation not change the value of the state variable. And then a variable name decorated with the exclamation marks represented output of the operations. And then a partial specification of a field operation. We have a partial operation means that operation is not uh, performed as a whole. Okay, we can find out this one is to check the storage tank by the measures of amount. This one as input, and then we choose this one as a natural number. Okay, natural number. Okay, and then storage tank field operation. If the storage tank amount input equal to natural number is z, overfill. Overfill, you doesn't want to change the amount of the tanks because the amount of the tank has been full in. Okay, and then we have R as a sequence of characters, and then we have capacity less than content plus amount, and R output insufficient tank fill cancel. Okay, and then we have field operations here by using disjunction operation that I have explained just now. We have field OK, and then we have to have the fully function. We use the disjunction. Okay, this one is specification that have a full operation. We have a container. Okay, second indicator, third storage, fourth field OK, overfill, and then six. Okay, okay. This one is we name we use the horizontal. Horizontal is like this. Horizontal like this. Okay, vertical like this. Okay, and then operation specification. Define the normal operation as schema. Define schema for exceptional situation. Operation may be specified incrementally as a schema. Then the schema combined to produce the complete specification like this. Okay, and then combine all operators by using or written as disjunction. one. Okay. Okay, and then to recap, schema includes three main aspects. First one is name, signature, and predicates. And then marks our schema, we have delta mean changes. This one based on the Greek. Uh, okay, based on the Greek languages. And then we have Z mean no changes. And then question marks mean input. Exclamation marks means output. And then single quote represent the values variable after operation. And this one is post condition. Okay, this one we want to define the set as a symbol of set. Okay, this one we define this one operation by the predicate. Okay, predicate. Okay, this one by the predicate define a relationship between entities. And then also using the logical expression that use the invariant. Okay, okay, and then we have here is we define as a set. Okay, this one is S is set of X, F is a finite set, membership, member, not member, subset, union, intersection, and so on. We have a natural number and Z for integers numbers. We have a maximum, minimum, and hash S is for cardinality. Okay, this one is partial function and total function. We have a domain F. Okay. Okay, do you have any question so far? If partial function in mathematics is a function from subset S of X, possibly X by itself to Y. Okay, like this. I think you have been learned in discrete mathematics. Here we have X and Y, and then we have element here A, B, C, D. Partial mean 2, 3, or D. Partial, not all the element in A. In X, covered all the function mapped to Y. Okay. Okay, and then we have logic expression by using negate P, negation. We have conjunction, disjunction, equivalent, and implications. Okay, as a recap, Z specification are made up of a mathematical model. Okay, and then also use some state representation and definition of operation on that state. Operation mean you define the predicate or set on that state. And then Z specification is represented as a number of schema. It depend on the domain of problems. If the domain like field tank operations, you need uh, fully functions operations. And then schema may combine to make a new schema by using a disjunction. Okay, disjunction. And the operation are specified by defining their effect on the system state. Okay, using the pre and post condition. On a pre and post condition. The operation may be specified incrementally. Okay, this one is we are using a partial or fully function. Different schema can be combined to complete the specification. And then the big concern here, notation is used very cryptic. Though great effort is made toward understandability, cryptic mean you need to to certain some symbols. Okay, this one is result specification example. Please study this one. Okay, we have a data dictionary specification. We have a given set. Okay, okay. And then this one is specification using function, and then this one is data dictionary modeling. Okay, we have add, loop, delete, replace, and extract. Okay, please please take note. This one. Read all of this, and later I will upload in a Padlet. And then after this, you need to do you need to do some reflection and upload to Padlet. Okay, class, do you have any questions? Aiman, okay ke? Ni banyak example kamu kena tengok balik lah. Ya. Mesti operation, static, dynamic. Saya dah terangkan tadi apa itu static, apa itu dynamic. Okay. Kalau static, I mean its state can be occupied, and then the invariant constraint that are maintained on the state and its value are changed. This one is static, whereby dynamic the operation that possibly on the state system. Relationship between operation input and output. Changes of state happen during the application of operations. Okay.